Hello everyone, welcome back to our YouTube channel. This is Dr. Rahul Srivastav, Assistant Professor, Faculty of Science Physics, the BHOPAL School of Social Sciences, Bhopal. As we have started this lecture series on the electricity, magnetism and electromagnetic theory, and this is the second lecture of this particular series. Now this one is dedicated to the Coulomb's law. As in the previous lecture we have discussed about the charge particles and how the material or substance getting charged and having the charge magnitude there. So just before going for the Coulomb's law, we are just having the brief recap of the charge. If you want to see that particular detailed description about the charge particles, how material or substance get charged, you can follow the previous lecture. Now as we all know that the charge is having two kinds, or we can say that the magnitude of charge is found in generally in two types of two kinds, that is the positive charge as well as the negative charge. These particular charging or the substances get charged because of the rubbing process. During this rubbing process, the transfer of electron particles from one substance to another substance will give the material to the positive charge value or the negative charge value, but equal in magnitude. Among these two charge bodies on rubbing, the charge on one body is equal in magnitude but opposite in nature. And this is what about the charges. As we have discussed in the previous slide, the example of glass material with the silk cloth. Once we are rubbing both these with the glass material and silk, the charge particles from one substance to another substance transfers. From the glass material, electron transfers towards the silk material, and the glass material is having the positive charge because of the loose of the electron particles and the negative charge particles, or because of having the additional negative particles, the silk get the negative charge, and this is how the material get charged, or we can say that the charge magnitude found in these particular materials. Another example we have discussed, that ebonite and fur, and multiple examples there. So this is how any substance can get the positive as well as the negative charge. Now also the important property, just before going towards the Coulomb's law, the behavior of these materials once they get charged. As we have discussed that once they are having opposite charge, means this one is having the positive charge and this one having the negative charge, or vice versa, means if this is the negative, this is the positive, the case is same, they will attract each other. The other or unlike charges attract each other, while the same charges, like this is the negative, this is the negative, if or in the case of positive and positive, they will repel each other. They will repel each other. So we can say that in all kinds of charges, or the attraction or repulsion there, the force is acting. The force is there, whether it is the attraction force or whether it is the repulsion force. Attraction force in the case of other or unlike charges, or repulsion force in the case of same charge, and every time the force is exerted there. And for this particular force, Coulomb has given the basic law with his experiment with these materials. Like before, I have given the example of glass rod, silk, ebonite, fur. These all materials has been experimented by the Coulomb. Charles Augustin de Coulomb, the full name, and in 1785 he propounded the law of basics by his experiment, and because of his experiment we found that Coulomb's law on his name. And according to this law, once we are having these two charge particles in the diagram, with we can see that this one is having the positive charge Q1, another charge particle Q2, and we are just taking the example of unit charge. The meaning of unit charge means the particles which are having a simple one magnitude negative charge, one negative magnitude positive charge, or either the same charges. So Q1 and Q2 are the 2 point charges or 2 unit charges. See, 2 point charges Q1 and Q2, and these two charges are continuously exerting force on each other. Once if they are having the same charge or same potential, like positive and positive, so they are repelling each other. They are putting the force on each other to repel, to part away from each other. While they are having the other magnitude, like positive and negative, in the case of Q1 and Q2, they are attracting each other and putting the force same time as well. So both the forces, whether it is the force of attraction F or whether it is the force of repulsion F. We have taken the example or the symbol F for the both attraction as well as repulsion, and this force is directly proportional to the product of the magnitude of the two charges, or mathematically we can say that F is directly proportional to Q1 dot Q2. Q1 is the magnitude of first charge, Q2 is the magnitude of second charge, and the multiplication or the product of both the magnitudes of charge particle is directly proportional to the force F, directly proportional to the force. So, this is what the Coulomb has told us or explained us about regarding the magnitude, that is Q1 and Q2 with the force. So, F is directly proportional to Q1 dot Q2. Another thing which he has experienced, that once the distance, see this distance r between these two particles, so the separated distance or the gap in between these two particles, once this gap is getting increased, the force is getting decreased twice or in square. So, we can say that the force of attraction or repulsion, same F, is inversely proportional to the square of the distance r, means F is directly proportional to 1 upon r square, or we can say that F is inversely proportional to r square. The meaning is that once the distance is getting increased, the force is decreasing by squares, or once the distance is getting less or the particles are getting closer to each other, they will feel more and more square in force. So, F is directly proportional to 1 upon r square. So, once we combined this formula, overall we can say that F is directly proportional to Q1 dot Q2 upon r square. That is what the Coulombs described about or regarding the attraction and repulsion force between two unit charge or 2 point charge particles. Followed by, if we want to remove that directly proportional, it will come as 1 upon 4 pi epsilon. As the symbol saying, force F, F is the force, whether it is the attraction force or the repulsion force is there. Also the Q1 and Q2, the magnitudes or the value of charge particles, r is the distance between charge particles, and the last one, the important one which we have not discussed yet, is the permittivity. Let me give an example regarding this permittivity. Epsilon. Let we are doing this experience in open space, like in a room, in a laboratory, or if we are doing this experiment inside the water. Once we are having two charge particles and they are having the free space, so they can move, they can travel freely anywhere. And once the particle inside the water, they cannot as much as in the free space. Or if we want to go in the dielectric material or in the solid material, then the particle will not be able to even vibrate sometimes because of the atomic structure of the solid, liquid and gas. So, this is what the epsilon is, the permittivity, means amount of permission that a particle is having to move is known as the permittivity or the epsilon. So, the epsilon meaning is that the particles are traveling whether they are having free space or not, whether they are having free space or not. For example, if we want to travel with the train and in the general bogie, we are going to or we want to go from one gate to another gate. It is quite tough because lot of persons are there. We have to cross them, we have to collide multiple persons there. Similarly, the case of solid, the lot of particles are there, they are completely overlapped to each other. Then we are just giving them to move, or we want them to move. If they are having same charge, they have to repel each other. If they are opposite charge, they have to attack each other. So, each and every time they have to travel and they are not even able to vibrate, then how they can travel. So, this is what the amount of freedom or the permittivity any material or any charge particle is having. So, in the case of solid, the permittivity is obviously the least, we can say that. In the case of liquid, it is having some flexibility to move, and in the case of open air, so the amount of freedom or the permittivity is very much high. And in the case of vacuum, so we can imagine that once nobody is there, the open space, the whole, the particles can travel anywhere. So, the maximum permittivity will be in the vacuum. So, this is regarding the permittivity epsilon 1 upon 4 pi epsilon naught. So, Coulomb has already defined all these things, but once we want to this experiment where we actually going to perform, this is regarding the epsilon. 1 upon 4 pi, obviously the pi we all know the value, and the epsilon is there, and this is defining the permittivity. Followed by the Coulomb's law in vector form. For the scalar quantities and vector quantities, as we all know, if you are having any confusion, you can go through the another videos that we have uploaded on the web in the YouTube channel. So regarding the scalar quantities and vector quantities, you can refer that. Now, Coulomb's law in vector form. Before that, we have not discussed the direction, the important one regarding the vector. Once we are saying it vector, means the direction must be defined that for example, I am applying some force on this end, I am applying some force. This is a normal. I am applying force anywhere. Now I am applying force perpendicular on it. I am applying force in this direction from north to south or from east to west, anywhere. Means once the direction is there, the quantity will convert it into vectors. If direction is not there, they are the scalar quantities. Before that, the Coulomb's law we have discussed, it's all about the scalar quantities. We have not marked anything. We have to apply force on perpendicular on this axis and that axis. We have not said that. Right now we are saying it. The force which we are applying, it has the particular direction, or it have to have the particular direction. Have to have, I am saying, because these charged particles are having the proper motion. If they want to have, then the proper direction must be there. For example, if the wall is there and the particle is there and the repulsion force is applying, one particle can travel this way by the repulsion force, but this cannot because of the collision of the wall. So that is what the meaning is. If we want to give the particle full freedom or the maximum permittivity, then we have to factorize all these things. So in this factorization or filtration, we have this vector form also, in which we will define the direction. For example, particle is there, so we cannot apply the repulsion force. We must apply attraction force. So it can move freely from this ball to this point. So this is what regarding the Coulomb's law in vector form. Mathematically, just we have put this bar, and this is the sufficient to define that the force which is applying in particular direction. This arrow, as we all know, obviously is for the direction. So this is what the Coulomb's law in vector form. Nothing additional, but just force with direction is the vector, and only force. We are not even discussing at all the direction, then scalar quantities. Now at last we are going to discuss about the significance or utilizations of Coulomb's law. As we all know that this is the one of the pioneer researches regarding the electricity and magnetism or electromagnetic theory, means whatever the things we are using in electronics, whatever the components we are using, whatever the devices we are using, this laptop I am using, all these things start with the charge particles. Imagine without the description of flow of charge particles, we cannot discuss the current. Once we cannot discuss the current, we cannot define the voltage. Or once we cannot define voltage and current, then resistivity will not can be defined. So how we can imagine the bulbs are glowing, the vehicles, electric vehicles are traveling, and all the regarding electrical electronics, these all depending on one thing, that is the charge or the charge particles. So Coulomb's have defined the relation between these charge particles, whether the force of repulsion or attraction. So first of all, the Coulomb's law is true only for the point charge. Before the popularly description of this law, we all just knowing that it is only for the point charge particle, but now it is also assumed to be true for the distributed charges as well. So on some theories, it has been proved that it is completely applicable for both the charge particles, whether they are point charge particles or distributed charge particles. Then this law holds the charge at rest. Matlab, it means that this law holds only for the charges at rest. We cannot define this, or this law cannot define those particles are already in motion. Force will act. Definitely force will act on them. They can disturb the path, but we are not having the proper description of it. So we are considering both the charge particles at the rest condition. Means before that they are just staying there for the next following forces, motion and all. So this law basically is only for the charges at rest for the complete description. The force between moving charge is obtained by the other laws. Some other laws has been defined by the other scientists regarding the, for example, nuclear forces are there, some other bonding forces are there. So, multiple things are there, multiple law define that. This law is based on the experimental results which we have discussed already. Coulomb with his own experiment proved all these things. And the last, the force acting between these two charge point charges is unaffected by the presence of other charge in their vicinity. We are assuming that all the forces are rest at there, means all the conditions are rest there. So, we are just having the neutral condition to follow or to define these particular situations. So, that is all for this particular lecture regarding the Coulomb's law. If you have any query, you can put in the comment box, and do like and subscribe our YouTube channel also. For today, this is Dr. Rahul Srivastava from BSS Bhopal. Thank you so much.